So exponential growth and decay. Formula is n equals n naught e to the kt, very similar to a equals pe to the rt. N's the population at the end, n naught is the population originally or at the beginning, and then k is your growth constant or decay constant. If it's positive, it's your growth constant. If it's negative, it's your decay constant. And then t is time. So the property value for a particular block follows a pattern. In 2001, you purchased it for, well, it doesn't tell you how much. And here's the equation that models the growth. So referring back to our basic equation, n equals n naught e to the kt. N naught is whatever that was at the beginning, at time 0. So part A is saying, what did your company pay for the property? That wants to know what is the value at the beginning, at time equals 0. So the value you paid will be the number in front of the E, 500. That's at time 0. Now, the only thing you have to be careful of is right here. It says that it's in thousands of dollars. So it's $500,000. It's the initial purchase price. Then also pulling from the equation, what percentage is the price of the property increasing? The percentage is your rate, or the K, which is right there, the 0.055. Since it's 0.055, change that to a percent by moving it 2 decimal places, so that is 5.5%. And it is increasing because it was a positive up there on the exponent. If it was negative, it would be decreasing. What will the property be worth in the year 2010? So since we are starting in the year 2001, 2010 is 9 years later, so we're going to do t equals 9. Just plug in 9 for t. So that's 500 e to the 0.055 times 9. And that's just a calculator work from there. So pull out your calculator and do e to the 0.055 times 9. Just make sure you put parentheses around your exponent so that it'll do the multiplication first. So that's 1.64. And then it's times the 500, the initial purchase price. So the final here is 820.249. Now remember, this is thousands of dollars. So this is $820,000. So there's a decimal point right here between the 9 and the 1. So it's actually $820,249.12. Since it was given in thousands of dollars, that's the value in 2010, $820,249.12. To figure out when it will be worth $750,000, you just set the whole equation equal to 750. And solve for t. So to solve this, you first divide by 500, trying to get the e by itself. I would reduce before you move on, so that's 75 over 50, which is 1.5. Then since the variable's up in the exponent, we're going to log both sides. So change this to a log. We get natural log because it was base e of 1.5 equals, now the e cancels out because logs equal the exponent. So now in our calculator, we're going to type in natural log of 1.5 and divide by 0.055 to get t by itself. Natural log 1.5 and divide by 0.055. We get 7.37. So when will the property be worth $750,000? 7.37 years later, and it starts in 2001. So what's 7.37 years after 2001? That'd be 2008, and about 4 months into it, probably. So whenever the question asks when, tell the actual year. If it says how long, then just tell how many years until it reaches there. So now we're going to look at some half-life. This is similar to what's used for carbon dating and stuff like that. This problem is kind of like figuring out how old something is based off of how much carbon's left. That's how scientists carbon date, to figure out how old something, an artifact or bones or whatever. So if an artifact originally had 10 grams of carbon in it, here's the decay model. That original 10 grams you can see in the equation right there, where the original value would go. And then they give us the decay constant. It's negative, so it is a decay, which makes sense because it decays. How many grams will be present after 25,000 years? Just plug in 25,000 for t. So this is only a calculator question. Plug in 25,000 e to the negative 0.000121 t. Plug in 25,000. Zero 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 121 times 25,000 years. And then it started with 10 grams, so multiplied by that initial 10 that was at the beginning of the equation. So we'd be left with 0.486. Round up to 3 decimal places, 0.486 grams. To figure out the half-life of something, you just want to know, that's figuring out how long until only half of it's left. Half-life means how half of it's left. So if we started with 10, half of it left would mean that there's 5 left. So you want to know how long is it going to take until there's 5 left. That's e to the negative 0.000121 t. And we're figuring out how long until there's half of it left. Half will be 5, so we're figuring out until there's 5 left. Now, with this, our first step is going to be to divide by 10. When you divide by 10, 5 over 10, that's 1/2. Every time with half-life, whatever you divide there is going to be 1/2. It's going to reduce to 1/2 because it's the half-life. You're always going to have half the amount on the left side of the equals as you do on the right side. So it's always going to reduce to 1/2. So then your next step would be to change this to a natural log. So natural log of 1/2 equals negative 0.000121t. The exponent comes down when you log it. That step's always going to happen also because there's always going to be an e. And on the next slide, we'll summarize that a little bit. So to finish this, divide by that decimal now, negative 0.000121, and that's going to be our final answer for t. So natural log of 1/2, or 0.5, divided by negative 0.000121, 5,728.489. We'll just say 0.5. 5,728.5 years. So it takes 5,728.5 years for half of it to go away, half of it to decompose. So what we were just talking about here with half-life, it's always going to be, this is K, and this is the formula for half-life. Half-life always will simplify to be natural log of 1/2 equals K times T. You could actually write that down as the half-life formula. Natural log of 1/2 is always going to equal KT. Because you'd always go through those same steps. You'd get 1/2 and then natural log both sides. And double time formula just works the exact same way. Half-life means there's half of it left. Double means there's 2 times as much. So you just replace the half with a 2.